All right, so we just got done with our first quiz and we're moving on to the second method for solving. We introduced solving quadratics and what that means in lesson 3. So the learning targets today is determine when it is appropriate to use square roots. So that right there's a clue. I said when it's appropriate. So it's not always appropriate. I can solve a quadratic equation using square roots. Okay, so at the end of the last lesson, I explained why solving a quadratic by graphing isn't always ideal. Just to recap, it takes a lot of time and it may not cross at a good point. Today, we're going to look at the second of 5 methods for solving a quadratic. This method is, for most people, the quickest, but it can only be used in certain situations. We'll talk about that at the end, okay? To get us started though, I'm going to show you an old thing. We're going to solve by graphing. All right, so I know we just got done doing that, but I'm going to do that kind of quickly. We get the AOS, so it is x equals 0. I'm going to just say that b is 0, so I know that 0 over anything is going to be 0. If I put 0 in, my vertex is going to be 0, -3. Okay, so we'll go ahead and put that there. Right? 0, -3 is the middle. -1, -2, 1 and 2. I'm going to do 1. So 1 squared is 1. 3 times 1 is 3. 3 minus 3 is 0, which means -1 is also 0. 2 squared is 4. 3 times 4 is 12. 12 minus 3 is 9. Okay, so I'm going to go ahead and plot those. -1, 0. 1, 0, 2, 9 is going to be up here. -2, 9 is going to be up here. Okay, and what are the solutions? Well, it's where they cross the x-axis, so it would be -1 and +1, right? So now I'm going to show you another way to get the exact same answers, but much quicker, okay? We'll go ahead and clear this. Keep in mind what the answers were. The solutions to the previous problem were -1 and +1. So here's the other way of doing it. First, let's get x squared by itself. So I'm going to move some things around. I'm going to move both 3's. I'm going to start by adding 3 to both sides. So 3x squared equals +3. Then I'm going to divide by 3. Okay, and I get x squared equals 1. Cool, I've got x squared, okay, by itself. Now, how do you get x by itself? You got to take the square root of both sides. Right? Now, this is where, if you're going to mess up, it's going to be right here. When doing that, you should get x equals 1, right? But look back at the graphing problem. How do we get the other answer, which is -1? Okay, this is something we haven't talked about, but when you take the square root of x squared, here's what you're asking. You're asking what number times itself equals whatever number the radical is equal to. So in this case, 1. What number times itself equals 1? We know that that's 1, but doesn't -1 also work? -1 times -1 also equals 1. We need to include both numbers. So we say that plus or minus 1. Okay, that takes care of both of them. And that's something like I said, I haven't talked about this. When you take the square root of a positive number, it's positive or negative root. Okay, and you're going to see that's a recurring theme. I'm going to go ahead and scroll down, go to the next page. This is a recurring theme in this unit. When you take the square root of something, you have to remember both the positive, which is easy to remember, but also the negative square root. Okay, so I'm going to do a few practice problems here. I'm going to scroll down a little bit more. We're going to do the same exact method that we did on page 1, and that is get x squared by itself. So I'm going to add 98 to both sides. I get 2x squared equals 98. Divide by 2. I get x squared equals 49. Okay, once you get to that point where you get x squared completely by itself, take the square root, and you get x equals, and a lot of people are going to put 7. Don't forget the plus or minus. Okay. Number 2. I'm going to subtract 4. You can see that once you do this a couple times, it gets pretty simple. Divide by 3. You get x squared equals 9. Square root, and you get x equals plus or minus 3. Okay. Number 3, subtract 32. I get 2x squared equals negative 32. Divide by 2. I get x squared equals negative 16. Square root. Now you can't take the square root of a negative number. This one has no solutions. A lot of people are going to ignore that negative and just say 4 or plus or minus 4. Keep in mind it's possible to have no solutions. Last one on top here. We'll subtract 25. I get 4x squared equals 0. Divide by 4. I get x squared equals 0. This is the one time when you take the square root of a number and get an answer where you don't do plus or minus. Plus or minus 0 is the same as, they're the same. So it's just x equals 0. Okay. Now I'm going to talk about what happens here. If I were to graph each of these problems, what would happen? Okay. I want you to make the connection between what we did previous lesson and what we're doing now. Number 1, the parabola would cross the x-axis at 7 and negative 7. Right? Those are the solutions. On number 2, it would cross the x-axis at 3 and negative 3. Number 3, what happened there? The parabola would never cross the x-axis. And the last one, what would happen there? The parabola would touch the x-axis at 0. It wouldn't go through it. It would touch it. Basically, the vertex would be at 0. Okay, so hopefully you made that connection between what we did in the previous lesson and this one. It can get a little bit trickier, but not a ton. It's just kind of bringing in some old stuff that we've done. Solve each quadratic using square roots. I don't want to see decimals. Okay, no decimals. So what I'm going to do is just add 64. I get 9x squared equals 64. Divide by 9. And right away, you're going to say, oh, 64 does not divide by 9. You're right. Don't change it to a decimal. Leave it as a fraction, 64 over 9. Now take the square root. Okay, the square root, and you get x equals, now this should be pretty easy. The square root of 64 is 8. Notice I put plus or minus right away. Square root of 9 is 3. There you go. There's your answer. They were both perfect squares. They were just in fraction form. So just take the square root of top and bottom, and you're done. So square root of 64 over 9 is plus or minus 8 over 3. And number 2, add 8. I get x squared, 1/3 x squared equals 28. I'm going to multiply by 3 to get rid of the 1/3. So I have 1x squared, or just x squared, equals, 28 times 3 is 84. Square root of 84 is not a good number. Okay. We just got done with a unit on radicals. Break this down. It's 4 and 21, 2 and 2, 7 and 3. I got 2 radical 21. Okay, that's how you'd write that, except it's not completely right because what did I forget? Plus or minus. X equals plus or minus 2 radical 21. All right, so I mentioned at the beginning of the notes that to use square roots, certain things have to be true. If you look back at all of the problems, you might notice a pattern, but let's see if you can figure out what that is. Why would square roots not work for this one right here? Let's go ahead and try it. Let's add 16. We're going to get x squared by itself, right? So we're going to get x squared plus 6x equals 16. And then I'm going to subtract 6x because I got to get x squared by itself. So I'm going to get x squared equals negative 6x plus 16. The square root of that doesn't make sense. Okay. Square roots only work. Okay. Yeah, let's go to the bottom there. In order to use square roots to solve a quadratic, the b value must equal 0. If you look back at the first 4 on the back page and the last 2, all of them had the b value equal to 0. Okay, that's key. If you don't have b equals 0, you can't use square roots, which is where the next lesson will come into play.